Hello, everyone. Today, our topic is about the VSU technology principle. And about this topic, we will have three parts. First, we will see some VSU overview. What is VSU and what's the advantage if we deploy the VSU in our network? The second part, we will talking some VSU working principles. If we form the VSU in our network, what's a special configuration and what's a special principle like the forwarding message, something like this, how to work. And the third part, we will talk something about the configuration. If you want to deploy the VSU in your network, what's the key command you have to add in your device and what's the limitation, how to select the device to deploy the VSU. So there are three parts. First, let's see some VSU overview. What is VSU? VSU, the full name is Virtual Switching Unit. And if you deploy the VSU, that means maybe you combine some physical device to become logical device. For example, you deploy two physical switches, and finally, in logically, there is only one. So this is a network system virtualization technology, not about the link. This is a totally network device. So if you use this technology, you can combine two switches into a single virtual switch. So if you want to do some management, if you want to add some configuration, you only control one device is enough. You can simplify the network topology and also can reduce the network complexity, and you can shorten application recovering time. And also, the most important one, you can improve the utilization of network resources. So later we will explain the principle step by step, then you can master what's the advantage of VSU. About the traditional network, for example, we will deploy three layers: the access layer, distribute layer, and the core layer. And in order to make your network more reliability, usually we will deploy multiple uplink layers and multiple uplink upper switches like this topology. Your distribute layer will have two upper interfaces to connect with our core layer switch. So in this scenario, if one link or maybe one device is broken, we still can communicate with each other by the backup path. But here, if you don't use some special technology, there is a loop. So how to use the backup link and also can avoid the loop, maybe you have to deploy the special protocol, we call it STP, or maybe some scenario you will choose RSTP or maybe MSTP. And then about the terminal, maybe they want to visit the other segment to communicate with each other, we need the gateway. If in our network, we only have one gateway, this gateway is broken, that means all the terminals cannot visit the other segment. So in this scenario, how to provide the gateway backup, you have to use the protocol as VRRP. So you will find you must select multiple protocols and to add the configuration to avoid some special scenario like the loop and the gateway backup. Multiple protocol must be used. And you also can solve this problem by the protocol, but there's some disadvantage because you now exist topology, we only have 6 switches, right? You can configure one by one, but in the real network, maybe there are 60 or maybe 100 switches. Your network is very big, so the management will be very complex. You have to manage one by one. The second one is Also, in order to avoid the loop, you deploy lots of STP protocol, but the disadvantage of the STP is if one link is broken, you have to detect and then to recalculate the backup link to enable the backup interface and then continue to work. And the fault recovery time is typically in the range of seconds. Also, maybe in RSTP and MSTP, you have lots of mechanism to increase the calculation time, but still several seconds to wait. So this is the second disadvantage. And the third disadvantage is some link will be blocked in order to avoid the loop. That means the whole bandwidth of the interface cannot be used. So this is the biggest waste of bandwidth. So this is a traditional network. If you deploy the MSTP and VRIP, and lots of resources cannot be used, and the management is too complex. So if we use the VSU, you will find you can get a reliable network and also can get a simple management. So VSU is virtual switch unit. This is a new technology. Then you can combine two physical switches in a single virtual switch. And here we call it typical network. We deploy two physical switch to become one single switch. But in some special scenario, maybe you want to deploy more than two switches, 3 or 4, it also can support the VSU. So the same topology, if you have the terminal user and the access switch and distribute switch, and between access and distribute switch, we have multiple links to communicate with each other. Then you can deploy the VSU. You will find the topology will be very simple. For example, here you add one link, then to use a AP interface, aggregate port, and then to use a VSU to make them to become one logical switch. And on the access switch, about the access switch, we also will think I only connect with one switch. So you also can add the aggregate port, the link aggregation technology. Then finally, the topology will be like this. So if you use the link aggregate between access and distribute switch, logically there only one link. So in the whole topology, there is no loop. And all the link can be used for the message. So we also can improve the bandwidth utilization. So this is the reliable. And then let's see the advantage if you deploy the VSU technology. The first one is you can simplify your management. The administrator only needs to connect one device. Then you can do any configuration, maybe on the first switch, maybe on the second switch. No need to change the console interface or maybe to change the web page to do different configuration. One device is enough. You can do all the configuration. And the second one is you also can simplify your network topology, like the previous page. If you use a VSU and the link aggregation technology together, then we will find the topology. There is no layer to loop. That means we no need to configure the STP protocol again. And also, we can reduce the protocol message like the layer 3 OSPF, right? If you have multicast service, maybe you have to deploy the multicast routing protocol like the PIN, and also some RCNP protocol and others, because your topology is very simple. The third one is you can make your fault recovering time reduced to milliseconds. That means if one link is broken or maybe one device is broken, the failover time is from 50 to 200 milliseconds. So it will be very faster. If one link is broken, we detect, then the backup link still can forward the message out. Maybe your application like the TCP connection will never find there is a failure, there is a fault. So this is a third disadvantage. And the last one, you can improve the bandwidth utilization because all the link and all the device can help us to forward the message out. And you can provide some load balance policy. Then all the link will use a policy to forward the message out. So this is an advantage. Then let's say if you want to deploy some basic VSU, there's some concept, you must know it. If you deploy the VSU, the switch will have two working modes. One is standalone and another one is VSU. If you first time use the switch, when we start the device, the working mode is standalone. That means all the switch will working independently and maybe calculate the switch automatically. And next step, maybe you deploy some other functions. This is standalone mode and this is default mode. Later, if you add some configuration about the VSU, like configure some switch ID, some domain ID, something like this, then you have to switch the mode to become VSU. Then between these two switches, we will do some negotiation to select who should be the master. Because if you deploy the VSU, we have to select one master, and this master have to calculate the topology, calculate some protocol, and finally to get some forwarding table, then all the devices can forward the message according to the forwarding table. So how to select who will be master and how to decide the next step, something like this. All of them master in the same VSU. And then they will do the negotiation to negotiate the parameters. So we have to change the mode to become VSU mode first. So these are two working modes. And of course, if you deploy the VSU, you can use a command to check the working mode. And in VSU, we have lots of parameters. Later, we will explain one by one. Like this, about the VSU, they master in the same VSU range, and how to recognize we are in the same VSU or not, we have to use the domain ID. And in the same VSU, how to distinguish different switch, we will have the switch ID. And as we see, in one VSU, we have one master. How to select who will be master, who will be slave device? If more than two switches, the rest of switches will be candidate. And who will be candidate? And we will select according to the priority. So finally, the master will have main chassis, and the second one will become standby. And we have two plans, control plan and the date plan. If the switch will become master, control plan and date plan will become active. But about the standby slave device, the control plan is standby. That means I will waiting everything from master. But about the date plan is active. That means if we receive some message, I also can check our forwarding tables, then finally to forward the message out. So we will have different plan. There are two modes. And later we will explain one by one what's the function of each parameters and what's the principle of these parameters. First, let's say the switch ID. And about the switch ID, this is a member ID of the switch in the VSU. And we limit the range from 1 to 8. And by default, the value is 1. That means by default, every switch, we will have the same switch ID. But if you want to add them into the same VSU, you must change the switch ID. Everyone in the same VSU, the switch ID must be unique. So you have to use a command to change it. And different switch ID will have different meaning, especially when you do the configuration. If we are in the standalone mode, that means you don't add the configuration of VSU. Our interface number is 2-decimal format. Like this one, gigabit Ethernet 2/3. That means slot 2 and the interface number is number 3. But if you change to become VSU mode, you also have to distinguish which device, which slot, and which port number. So we will have 3-dimensional format, like gigabit Ethernet 1, 2, 3. The first one is a switch ID. The second one is a slot ID. The third one is a port ID. So we have different meaning of each number, and how to recognize what's a switch ID. You can use a command show switch virtual, and then the first line is a switch ID number. 4 switches here on the VSU, and what's the switch ID 1, 2, 3, 4. And you also can change the number to become like 1, 2, 5, 6. It don't matter. But the key point is you have to make sure every device number in the VSU must be unique. So this is the first one about the switch ID. And the second one is the domain ID. And the domain ID is identifier of VSU and is usually distinguished for different VSUs. And if you want to deploy multiple switch in the same VSU, you have to give same domain ID. And the domain ID range is from 1 to 255. The default value is 100. So you can use the command to change the domain ID. The command is switch virtual domain, and then to give the domain name give the domain ID. By default is 100. And if in the VSU status, that means you already deployed the VSU successfully, then you want to change the domain ID. You have to use this command. Switch, which switch change which domain ID. And then you have to save the configuration. And later, if you change these parameters, the switch will restart. So pay attention about this one. And also you can use the command show switch virtual. Then you will find 4 switches in the same VSU. Their domain ID will be same. All of them will be 1. So pay attention about this one. And another one is one device only can be in one domain. If you already add the switch 1 in the domain 1, you cannot add this switch in domain 2. When you delete the configuration of the VSU, delete the domain, then you can add the switch 1 into another domain. It can work. So this is the domain ID. And the next step is the priority. We see in the VSU, we have different rules. We have master, we have slave, we have candidate, and how to select. One key parameter is priority. So we can use the priority to select who will be master. And the value is larger priority value, so more likely will become select master device. And the value range is from 1 to 255. The default value is 100. So you can use command to change the priority. For example, like this example, we want to let the switch 1 to become active, right? Active means the master. So you can change the priority to become 200. And the 200 highest will become the master. The second one will become the standby. The rest of them will become candidates. So this is a priority. And pay attention. When we select master, by default, we will compare the priority. The value higher will be better. But maybe some scenario, we don't change the priority value. That means our value will be same. All of them will become 100. Then we will compare the switch ID. And the switch ID smaller will be better. That means switch 1 will be better than switch 2. And in some scenario, someone also can forget to change the switch ID. That means 2 switches will use the same switch ID. All of them will become switch 1. In this scenario, only 1 switch will become VSU successfully because the switch ID are same. Who will be select master? We will continue to compare the MAC address. MAC address smaller will be better. So finally, compare one by one. We will select one device to become master. First, compare the priority. Value bigger will be better. If the priority are same, we will compare the switch ID. Switch ID smaller will be better. If switch ID are same, we will compare the MAC address. MAC address smaller will be better. So pay attention about this process. And here, if you use the command show switch virtual, you will see 2 values of the priority, right? And about these 2 values, the first 200 means the priority of current operation. And the second 200 means the priority of current configuration. For example, now we change the priority from 200 to become 255. But finally, this value will become 250. And if you restart successfully, this value will become 250. So this is a relationship. And the next one is the status. And we have 4 status. The basic one is okay. If the status is okay, that means we already select successfully. And this is a standard status. But maybe some special scenario, you will see different status, like recovering. Recovering will happen if one VSU is split and the BFD or maybe link aggregation detector is configured, the standby device will be in this state. That what may and which scenario that the VSU will be split. First is between these 2 switches. First time we already form the VSU successfully. Then maybe between them the link is broken. And this special link we call, later we will explain, we call it VSL link. If this link is broken, and the 2 switches will become 2 VSU. So in this scenario, some configuration will be same and the network will be broken. So we hope the standby switch can be in the recovery status. In this state, all the interface cannot forward out the message. They have to wait. Maybe the network will be recovered. Then we have to select who is master, who is slave. Continue to work. So this is the first scenario if the VSU system is split. And the second scenario, if 2 split VSU systems are merged, that means maybe between them the link is recovered. Then the side that lost the election is also briefly in this status, briefly time. So this is a recovery. And the third status is leave. It belongs to the process state and only exists during the restarting process of the device. First time when we configure the configuration of VSU, we have to restart the device. And in the short time, we were in the leave process. Maybe we still have to negotiate the parameters with each other. And the next one is isolated. The isolate means the switch IDs are same. For example, when we do the configuration of VSU, by default, we have to change two switches, the switch ID to become different. But maybe some scenario you forgot the configuration and directed to change the working mode from standalone to VSU mode. So in this scenario, when we negotiate the parameter between these two switches, we will find the switch ID are same. So the lower priority, maybe it's a priority we set, maybe it's the MAC address is smaller. This lower priority switch will be in the isolated state. And all the VSL link will be in the down status in order to make our network successful. Okay, so these are 4 status. And also you can use the command show switch virtual to check the status. If all the configuration are correct, we will find the state will become okay. And here is a note. If one device in recovery status, we will put all interface in shutdown status except the VSL interface and some special port we add the configuration except port. So when a recovery status device detects a non-recovery state neighbor, it will automatically reboot. That means, for example, now the system is split and then the link is recovery. We will continue to negotiate with each other and except the master, the rest of the devices will reboot again. So these are the status we have to know. And the rest of them is the rule. We have 3 rules: active device, standby device, and candidate device in one VSU. Maybe in your network, you have multiple VSU. In one VSU, there only one device will become active device. Only one device will be standby device. The rest of them will be candidate. And how to select the active, we already know it, compares priority, right? Priority value is bigger will be better. If priority is same, we will compare the switch ID, smaller is better. Then we will compare the MAC address, smaller is better. So what's the function of active? You have to manage the entry VSU and is responsible for synchronization configuration time to all the member devices. Right? When we do some configuration like the OSPF, this configuration have to synchronize to all the devices. This is a function of the active. And how about the standby? And about the standby device, the control plane will be in the standby status. And about this switch, we have to detect if the active device is working or not. If the active fails, that means the standby will automatically upgrade to become active and take over the work of origin active device. So this is a function of the standby. Only one thing, we have to detect the active device is working or not. Then the rest of devices will become candidate device. So there are 3 rules. And if the standby device fails, then we have to select one candidate to become standby. And also, the new standby will detect our active device is working or not. But if active fails, pay attention. If active fails, the standby will become new active because standby has everything from active. Then we will select one candidate device to become standby. So these are the process. And also you can use the show switch virtual, and then you will find the rule, active, standby, or candidate. So they are basic one. And the next concept is a basic VSL link between two switches, or maybe more than two switches, 3 or 4 switches. How to connect with each other? We will use a special link, and this link will be added to become VSL link. And this VSL link is a special aggregated link. And on this link, usually we will transfer some control information, and also you can transfer some data message between them. But usually we will transfer some control message. For example, how to detect our neighbor is working or not. How to do the negotiation to select who will become master, who will become backup, something like this. And the VSL ports usually exist as an aggregated port group, so you can improve your network reliability. And about the VSL member port, when we add the configuration, how to select the interface to become VSL interface. You have to select the physical port for the VSL port connection, can be stack port, Ethernet port, and also can be optical ports. And this interface can select to become the VSL. Because about the VSL, not only for the control message and the user data message, but also used to detect the state of all the switches. So the reliable is very important about the VSL link. So when we deploy the VSL in our switch, it is recommended to configure at least 2 VSL links in one switch. If one link is broken, we can continue use the second link. If it is high-end switched from a VSU, it is recommended to use different line cards to form a VSL. For example, you can add multiple LAN cards in one device. You can select the first slot, one interface to become VSL, and also the second slot, another link, another interface to become the VSL link to communicate with each other. It also can provide a higher reliability. So this is a basic concept. When we deploy the VSU, you have to know what's the different meaning in them. And the second part, let's say the VSU working principle. If you deploy the VSU between 2 switches or more switches, then we have to use a VSL link to connect with each other. And between 2 switches, we will not use the original Ethernet message again. We will use some special high HG message. And here are the message, different one. If we use the regular Ethernet message, we will have header and some payload and some CRC check, something like this. But about the HG message, we will encapsulate some special encapsulation of the Ethernet message. And also about this part, we don't need to remember what's the detailed meaning of each segment. And that ain't no need, because if we deploy VSU successfully, then once the switch receives a message, if the message needs to be forwarded in the VSU system, they will do the encapsulate automatically. So we don't need to remember what's the detailed meaning in each segment. But you have to know between VSU, they will use some special message belong to the VSU. And later, let's say the VSU control plane principle. Logically, for example, like this topology, if we deploy the VSU in switch 1 and switch 2, switch 1 to become active, switch 2 to become standby, and between them we have VSU link. Then we deploy them to become the same VSU. And about the SW3, the switch 3 will think I only connect 2 interface with 1 switch, right? Because they are in the same VSU, they are 1 logical switch. So logically, each member of VSU is regarded as a device with only 1 entry. But in fact, each member switch 1 and switch 2 still maintain its own entry information. But the special one is the member entry information is consistent. So each device will have some forwarding table, but the forwarding table information are same. Then when we receive the message, how to forward the message out? We can divide the forwarding to become local forwarding and non-local forwarding. Like this, about the local forwarding. Local forwarding means like this switch, I receive the message from the other switch out of VSU, right? I receive it. And I would check my forwarding table. I found my inbound and outbound interface are on the same member device. And this forwarding we call is local forwarding. So when we receive this message, we will check our local forwarding table, and then finally to find the outer interface is connected with another switch. Then the switch will directly forward the message out. So this is a local forwarding. And when we forward the message out, we have one principle is local forward first. By default, the local forwarding first is enabled. If this feature is disabled, that means when we receive the message from the other switch, then we will directly forward the message according to AP. AP is aggregate port, right? Or maybe RCNP configuration rules. That means I will select some link randomly because this is the aggregate port. So if you use this principle, the AP principle or maybe RCNP principle, finally we will select the suboptimal forwarding, not the best path. So you can enable the local forwarding first function. And we also can support 2. One is AP local forward first. You can use the command switch virtual aggregate port LFF. LFF is local forward first. Then we can support the AP local forwarding priority LFF. And also we can support the RCNP. But by default, this is a local forward first principle. If I receive the message and the outer interface were located on my interface, I will directly forward the message out because this path will be better. And if we use a layer 3 switch deploys a VSU, we can configure the IP-based AP load balance mode to support the message forward out, provides a load balance function based on the source IP or maybe destination IP, or maybe source and destination IP together. And another forwarding is unicast forwarding. That means if when we receive the message, we found the interface and outer interface for forwarding packets are on indifferent member. Because for these 2 switch, on the physical topology, we will find they connect with 2 switches, right? But totally logically, we will about these 2 switch, we will find we connect with 1 switch, 1 logical switch. But internal, the inner interface and outer interface are located in different switch. So once the switch 1 receives a message according to the forwarding table, I will directly forward the message to another switch, switch 2. And when switch 2 receives it, I will directly forward the message out. So this is the basic about the forwarding table. So now we talk about the basic one about OSPF overview and also OSPF working principle. Later, we will talk about the VSU configuration.